So today our topic. First, sorry for late because I have a another training just now, so I'm late today. And today, we will continue to introduce our VD3 product. And today I will introduce CSV control mode. In the last training, we have already introduced CSP control mode. So it's similar to use our driver in CSV controller. But there will be one thing difference. Today I will show you how to configure it with Ctrl C software, LX6C. And if you joined the last two training, you will see the configuration is similar between 6C and 6V. And today our training will last about 20 minutes. Okay, first, the introduce of CSV control. CSV means cyclic continuous velocity control. And it's similar with CSP. CSV control. The controller control our in this training is our 6C. So the controller will send the target velocity to our driver, and the driver will control the motor to rotate to follow the target velocity. And in every synchronous cycle, the target position will always updates. So the speed of the motor will always be updated. And here I have some relative dictionary objects of the of CSV control mode. And I will introduce them one by one later. And some applications for CSV control. Almost all application need speed control. We can use CSV control. And here, for example, automatic production line, CNC control, and textile machinery. Okay, we can have an easy look and continue. Okay. So some relative object dictionary. In this table is some relative object dictionary, and I have already used red color to mark some important or widely used object dictionary in CSV mode. For example, control word, stator word. For these two, I have already introduced them in CSP, but not in details. So today I will introduce these two in details. And operation modes, velocity actual value, max speed, and speed offset. Here for this accessibility, usually RO means read only. Usually RO is input object dictionary. I mean it's no parameter from driver to feedback to our controller. And for RW means read and write. Usually for this type is output parameter. It means controller sent this parameter to driver. And also we have this. Let me check. Max. Okay. Yes, this one is our target velocity, profile velocity. Okay. First, server mode selection. Today we use this CSV mode, so we need to set this parameter as 9. and you will see our panel will show number 9 in this position. And these three parameter. This three parameter is our actual velocity, target or profile velocity, and the max velocity limit. Usually we use these three parameter for speed control. And also we have forward speed limit and reverse speed limit. If you need this parameter, you can also add it to your PDO configuration. And control word. For this, we can use this object dictionary to enable our driver. Default value is 0, and if you want to enable the driver, you can see here bit 0 means server operation can be start, and bit 1 means turn on the main circuit, or you can understand it as give power to driver. And also bit 2, bit 3. Bit 3 is servo operation. So in a word, if you want to enable the driver, you can set these 4 bits. These 4 bits of this object dictionary as on status to enable your driver. And also you can use some function block, for example, MC power to enable your driver. In Cortex and in 6V, we both have MC power in function block. And also stator words. These stator words will show the servo driver status. For example, bit 0 is servo ready. And when servo have any error, you can see bit 3 of these stator words will turn on here. And in our last training, I have shown you bit 10. Bit 10 is target arrive. I show you we set a target position, and when the actual position achieve the target position, this bit 10 of 6041, this object dictionary will turn on. And here also have a status, a table of different status of a driver. For example, when servo is in enable status, you will see the stator word of driver will in this form. And when servo have, for example, have a fault, you will see the servo stator words will be this value, this form. Okay, now I will show you how to connect VD3E to 6C. We can check this video first. And okay, we can start from beginning, because maybe some people haven't used Cortex before. Yeah. This Cortex software, you can download it from our Wecon support center, or you can download it from website of Cortex. And in the end of this month, we will develop our Wecon Cortex software and we call it as Wecon 6. And also I have a video I can show you in the video. Like this, uh, right side is our Wecon 6, and the left side is code 6. We change the logo and change the name of the software and some interface. In the video, it shows by Chinese, but we will also support English. The interface is similar, and also we will for now uh, we have another software called it as Wecon called this tool. This tool is used to set the IP or read set the time of PLC or read some firmware information. But in the future, when we have our own software, we will add this tool to the software, built in this tool to our software. So we don't need to install two software for our RX 6C. Okay, so here we click new project to create it one project. And select the model and the programming language. Here in tools, you can change the language, tools and the operation. Here I have an international setting. And this is the language support in codices. You can select the one to use. Okay, so for now we need to connect PLC to our PC. So here we double click device and click this CAN network. And now you need to use a Ethernet cable, connect your driver to your PC or switch to connect it to your PC. And the default IP of our 6C is this one. It's same with 5 series and 6 series 6V. Oh, sorry. Default IP, this one. So you can change your PC IP or use Wecon quality tool to change PLC IP. And after is this video. After connection, like this, you will find it in here and click OK to connect it. Okay, after connecting, we need to add in device. We right click add device, and here we need to add sketch master soft motion. At this device, it means our controller is sketch master, and here we continue to right click in this sketch master to add device, and in the list you will see the servo driver and input the firmware. Sorry, input the ESI file of our driver. And here I have 3 different versions. So you also need to check the firmware of your driver in monitoring value to U2 and 4. U2 and 4. In this monitor value will show the firmware of your driver. And we need to use same firmware. What about now? I will show you. monitoring. And this U2 and 4, this is your firm version. You can check it. And in codices here, select a same version. Select a same version to add. And if you don't have this, for example, you don't have this V1.10, 1.12, or 1.11, you can import it. How to import? Tools and this device. And here in this page, you can install the driver. This is the ESI file of our driver. And where can you download this ESI file? You can download it from Wecon Support Center here in server. I will send uh, the link to our WhatsApp group. Okay, we can continue. I will send the download link of the ESI file of Java to our training group later. So here, continue. So after add this, add this driver, we need to set the MAC address of our PLC. Oh, sorry, yes, of our PLC here. Double click EtherCAT master, and in January, we click this select and click this one network name ETH1, and click this login. Login means download the project to PLC and the internal monitoring mode. And this means run the project. And here, when this color change to green, means the communication is normal. Okay, so this is how to add EtherCAT slave. And after adding the slave, we can add some object dictionary. Here, double click our Java and check this expert settings. And then we will have this expert process data. It's sent in 6 series. You can see here. You can add one file, EtherCAT. And select. Here we have one output group and one input group. Here in output group, we have uh, three PDO to three PDO group to select, but we can select one and send time. And for input is send. We can only select one. And here we can, for example, for output, we can add some PDO operation. For example, here, this control word and operation, a mode of operation, and this max velocity, speed offset, and this target velocity. You can add it in our output group, and also you can add, for example, actual speed, actual velocity in this input group. You will see here in each group we have some default objects. If you don't need it, you can delete it from your PDO group and add some unit. Okay, so here. Okay, after adding after the configuration of PDO. Okay, after configuration, we can compile and log in again. And the last for velocity control. Here. After the PDO configuration finishes, how to change the value in 6C. In 6V we map this PDO to our variable and change the variable in program to change the value. And in 6C is almost same. You can see here uh, here we have also have EtherCAT IO mapping. Okay, this is our configured PDO. And in here, IO mapping, we can also map this object dictionary to the variable in our program. So here you can add some variable in your project and map this PDO to your variable. And during program running, you can change the variable to change this parameter. And here I change the setting. Sorry. Okay, check here. Here I have a setting. Always updates variables. Default is this use parent device setting. It means you have to add this. You have to, for example, you map the list to variable. You have to use the variable in your program. Otherwise, this parameter will not be updated. But here I change it to this enable one. This means we don't need to map this PDO to the variable. We can directly change the value in this interface. So here. Okay, so here after changing, compile and log in. You can see here it's 49, and later it will change from 29, 48, and 88. Here is the changing of the panel. 2 means pre-operational status, 4 means safe operational status, and 8 means operational status. So here, when I change the mode of operation to 9, you will see here will change to 9. And the target velocity. Target velocity. And then the max velocity. Now I change this control word. I set this four bits as true and write the value. Now the driver is changed to RN status, run status. And here you can see target at target this position actual value is changing because the motor is always running. And when I change the target velocity, this velocity actual value will also change. This is 40,000, and then the actual speed is changed to 40,000. Okay, so this is the speed control in CFC control mode. Do you have any questions? Here you will see after we change the target velocity, the motor of the speed of the motor will immediately to change its status because we are running in CSP mode. CSP mode, so it means after I change the target velocity, in the next synchronous cycle, the motor will immediately change its velocity to the target velocity. So I mean the motor speed will change suddenly. So usually in your program, we need to set for example, a speed curve to change our speed. It will be safe because there are no acceleration and deceleration. But only in PV mode we will have acceleration and deceleration. In CSP we don't have these two parameters. For soft motion control, because it's different with CSP modes. I mean, in CSP modes, position control, you have some, for example, absolute move, relative move, and EGO or ECAM or some soft motion. But for CSV is just speed control. So there are no many function block used for CSV control because it's just we just need to control the speed and make it run in a target speed all the time. So here I didn't show some function block relative in CSV mode. Yes, and in fact in application, most most application are used CSP mode, and some and others maybe talk control CST, and then is CSV. Okay, okay, and this is our uh, today's training about CSV control by 6C. You will find is because some people said they don't have 6V, but they have 6C. So in this training I changed to introduce it by 6C. But in fact the configuration of these two is similar. We have PDL configuration and for example variable mapping and so on. It's similar. Okay. Uh, okay, that's all today's training. Thanks for attending. And 2 days later, in this uh, Thursday, I will introduce CST control. And if you have VD3E, you can try this control mode to connect and run it. Okay, thank you, and see you. Bye.